Hey guys, so in this video we're going to look at inverse functions. Now what exactly is an inverse function? We can define it as the following. The inverse of a function f is the function that undoes or reverses the operation of the function f. It is denoted by f to the power of minus 1. This is f inverse. It exists if the function f is a one-to-one function. Now to better understand this definition, let's start by looking at an example. Let's say that I have the function f of x is equal to 2x minus 3, and this is defined for all values of x greater than or equal to 0. And let's say over here that y is equal to f of x, right? So the output over here is y. Now what's the domain and the range for this function? Well, we already know the domain, right? We restricted the domain. The domain over here is all real numbers greater than or equal to 0. In other words, x is greater than or equal to 0. And the range for this function, is f of x is greater than or equal to negative 3. Or we can say that y is greater than or equal to negative 3. So we have the domain and the range for this function. Now what I want to do here is I want to find the inverse function for this function. In other words, I want to find f inverse of x. Now how do I do that? Well, let's start by looking at some of the possible values of the input over here. In other words, let's look at some of the values of x in the domain for this function f and the corresponding values of the output y. So here we know that for x is greater than or equal to 0, right? When x is equal to 0, y is equal to negative 3. So when we apply the function f to the input x over here, when x is equal to 0, when the input is 0, the output is negative 3. When x is 1, y is negative 1. When x is 2, y is 1. When x is 3, y is equal to 3. And when x is 4, y is equal to 5. So here we have some of the possible values of the input x and the corresponding values of the output. And we know that since x is greater than or equal to 0, when x is equal to 0, y is equal to negative 3. And then for any value of x greater than 0, we see that y will be greater than negative 3. So therefore we can say that the range over here is y is greater than or equal to negative 3. Now how do we find the inverse function, f inverse of x? Now we know that the inverse of f is the function that undoes the operation of f. Now over here what f is doing is taking the input x, it's multiplying the input by 2 and then subtracting 3 to give us the output. The inverse function will take these values and it'll return the values of the original input, since it'll reverse the operation. So if the function f is taking us from 0 to negative 3, for example, then the function f inverse will take us from negative 3 back to 0. And we can see that over here. When the input is 0 and we apply the function f, the output is negative 3. For the inverse function, if the input is negative 3, the output is 0. Similarly, when the input x is equal to 1 and we apply the function f to it, we get the output is negative 1. And for the inverse function, it will reverse the operation of f. So when the input is negative 1, the output is equal to 1. So then how do we find this inverse function? Well, we know that for the original function f, when x is the input, y is the output. So over here, since y is equal to f of x, we can say y is equal to 2x minus 3. And for the inverse function, these values of y will be the input and the output will be the original values of x that were the input in the function f. So here, the output is x and we want to find x in terms of y. In other words, we want to make x the subject over here. So we can do that by adding 3 on both sides. So we get 2x is equal to y plus 3. And then we divide both sides by 2 and we get x is equal to y plus 3 divided by 2. So here, for the inverse function, the output here is x and the input here is y. So we can say that f inverse in terms of y is equal to y plus 3 divided by 2. And here, since we wanted to find f inverse of x, we can simply take the input as x instead of y. And we can say that f inverse of x is equal to x plus 3 divided by 2. Here I've simply substitute the input x instead of the input y over here. So here we found the inverse function, f inverse of x, for this function. Now let's go back to the definition. The definition says that the inverse of a function f is the function that undoes or reverses the operation of the function f. So if we go back to the function f, we know that the function f takes the input x, it multiplies it by 2 and then subtracts 3 from it. If you want to reverse those operations, what we're going to do is we're going to add 3 to the input and then divide it by 2. So here we multiply by 2 and then subtract 3. And for the inverse function, we add 3 and then we divide by 2. So what we're doing is we're reversing the operations of the function f step by step. And that reversal of those operations gives us the function f inverse of x. Now, what is the domain and the range for this function? Well, we can clearly see over here that the domain for the inverse function, right? The domain for the inverse function, the set of inputs for the inverse function is the set of outputs for the function f. In other words, the domain for the inverse function is the range of the original function f. So the domain over here would be x is greater than or equal to -3. The range of the function f of x is the domain of its inverse f inverse of x. Now, what's the range of this function? What's the range of the inverse function? Well, we know that the inverse function, the set of outputs for the inverse function, that's the range, is the set of inputs in the original function. In other words, the domain of f of x is the range of f inverse of x. So here we can say that the range is f inverse of x will be greater than or equal to 0.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
So then we can say over here that the range of a function is the domain of its inverse. So if you look at the function f of x over here, the range of the function f is the set of outputs given by that function, and that set of outputs will be the set of inputs for the inverse function. So we can say over here, the set of inputs for the inverse function is the domain. So we can say that the range of the function f is the domain of its inverse f inverse of x. Similarly, since f and f inverse of x are inverse functions of each other, we can say that the inverse of f inverse of x is the function f of x itself. So we can say again that the range of the function f inverse of x, that's the set of outputs given by f inverse, will be the set of inputs for the function f. So again, that will be the domain of the function f. So the range of the inverse function, f inverse, will be the domain for the original function f. Similarly, we can say that the domain of a function is the range of its inverse. So again, if we look at the function f over here, right, if we look at the domain or the set of inputs accepted by this function, that is the same as the set of outputs for the inverse function. So that is the domain of the function f is the range of its inverse function, f inverse. And the same thing applies here. The domain for the function f inverse, that's a set of inputs accepted by f inverse, is the range or the set of outputs for the function f. So then what we can say regarding inverse functions is the following. That if I have an input x and I apply the function f to it, I get the output f of x. And the function f inverse will undo or reverse the operations of f of x, and it will return the original input x. So when I apply the function f to x, I get f of x, and when I apply the function f inverse to f of x, I'll return the original input. It'll reverse the operation of f. Similarly, if I have an input x, I apply the function f inverse to it, I get f inverse of x as the output. And since f is the inverse of f inverse, if I apply the function f to f inverse of x, this will reverse the operation of f inverse and it will return the original input x. So consequently, we get the following relationship. The composite function f inverse f of x is equal to f inverse of x, and that's equal to x. So this f inverse of f is this relationship here. We first apply the function f to the input x, and then we apply the function f inverse and we return the original input x. Similarly, if I apply the function f inverse first to the input x, I get f inverse of x, and then when I apply the function f to that, again I reverse the operation of f inverse and I return the original input x over here. And we can verify this relationships by computing each of these composite functions. So first, let's compute the composite function f inverse f of x, right? And that's the first one over here, right? How do we do that? Well, if you look at the function f inverse of x, we're taking f of x as the input in the function f inverse. So we have f inverse of x is equal to x plus 3 divided by 2, but now instead of x as the input, we're going to have 2x minus 3 as the input. So what we have over here is we have 2x minus 3, that's our input, 2x minus 3 plus 3 divided by 2. And this gives us 2x divided by 2, and this is equal to x. So we've shown that f inverse f of x is equal to x. Now let's compute the next composite function, that is f inverse of x. Here we're going to be taking the function f inverse as the input in the function f. So we can say over here that we know that f of x is equal to 2x minus 3, but now instead of x being the input will be f inverse of x. So what we have over here is we have 2 times the input, so that'll be 2 times f inverse, that is x plus 3, divided by 2 minus 3. And what we get over here is we get x plus 3 minus 3, and that again returns x over here. So we can prove that these two functions are indeed inverses of each other by simply proving that these two compositions, the composition of a function and its inverse with a given input, will always result in the input itself. Now the last question over here is, how do we represent a function and its inverse graphically? In other words, what is the graphical relationship between a function and its inverse? Well, we have the following property for inverse functions. We can say the reflection of the graph of a function across the line y is equal to x gives the graph of its inverse. So here we can see the graph for y is equal to f of x, that is the line y is equal to 2x minus 3, and if we reflect this line across the line y is equal to x, if we reflect 2x minus 3 across the line y is equal to x, we get the graph for y is equal to f inverse of x. In other words, we get the line y is equal to x plus 3 divided by 2. Now how do we explain this relationship? Let's take an example of a point on the line y is equal to 2x minus 3. In other words, on the graph of y is equal to f of x. We can see over here that when x is equal to 2, and x is equal to 2, y is equal to 1. So we can say we have the coordinates of the point 2, 1 over here. And if we reflect this point, across the line y is equal to x, what that means is reflection across the line y is equal to x simply means we're switching the x and y coordinates. So if we reflect this point across the line y is equal to x, we get the coordinates 1, 2. We're switching the x and y coordinates. So this is a reflection across the line y is equal to x. And we can interpret this in the following way. We know that if we look at our function f of x over here, right, and we have the graph for y is equal to f of x, we know that when the input x is equal to 2, the output y is equal to 1. The inverse function f inverse of x undoes or reverses the operation of f. In other words, for the inverse function, when the input is 1, the output will be 2. So for the inverse function, or for the graph of y is equal to f inverse of x, when the input x is equal to 1, the output y is going to be equal to 2. We've simply said that for the original function y is equal to f of x, when the input was 2, the output was 1. Whereas for the inverse, or for the graph of y is equal to f inverse of x, when the input is 1, the output is 2.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.